Good morning, everyone, and welcome to Code with IJ. And today we are going to be talking about build smarter Elixir principle to maximize productivity and prevent breakage. So the problem case we're trying to solve is that we have seen various scenarios, not just on Elixir developer, but developers as a whole, where you push your code to production and all of a sudden it just break, the system crashes, and so many things happen. Or as a developer, you're writing your code, and when another developer tries to take a look at it, they are fully confused of what are you going to do here. So in this video today, we are trying to break down principles, or yeah, I'm going to call it principles, because why I'm going to call it principles, because it's a norm or something that you should put in mind why developing an application or why being a developer. So our next slide, so we're going to move this next slide and say why this matters. So why does these principles matter? One, you reduce production bugs. So the QA team, the QA testers, and your users don't have to face some bugs that are because of you. Why, after you have developed your application, improve team productivity, it help everyone in the team able to communicate and build a very resilient product. Three, it creates maintainable and scalable system. Why are you coding as a developer? Is it not to build a system that when, even if you're no longer part of that project should be able to last 50, 100 or 200 years? If you look at WhatsApp till now, the first feature of WhatsApp that was being built, I don't think the developers are still there maintaining the code, but because they write a very clean and sustainable code, people coming into the project can always pitch line and continue from where they stopped. The second step is principle one, keep it functional. So before we talk about principle one, keep it functional, I want to ask you, when they give you a project, or when your project manager or your product manager give you a task, how do you look at this task? Did you just dive into the code and start working on it, or do you try to see it as a journey, as a roadmap, and step by step try to understand, oh, what is this user going to face at this step of the way? Try to write a proper documentation of the code, do a data structure if it's a back-end work, do a data structure if it's a front-end work. Try to break it down to your own understanding and have a meeting with your product manager or your project manager to understand if you're in the right guideline or if you're in the right step towards how to maintain this task. So it brings us to our number one principle: keep it functional. Pure and simple functions. When you break down function into small reusable components and something testable, is enough for other developers to use your code. And for you, when you come to that code, maybe 5 or 3 months later, you're able to understand what you did at that point in time. So for example, look at this code. So we are trying to fetch a user, want to transform the user, and want to send me. So this is like three different functions where we have broke down the code. So there is a fetch a user function where we are fetching the user with the ID. When we get that user, we are transforming the user, probably getting the user email and the user phone number, putting the first name and the last name together in a string, and getting the user email and every information we need before we send an email. So this is just an example of how to keep your code functional. So the next principle is pattern matching for clarity. In Elixir, there's this cool, and I think not just Elixir, every programming language have it, pattern matching, where you create a pattern to say this is what I'm expecting. If this is in the system, do this. You should write your code like if you are telling a story. That way, in when you are debugging your code, it's easier to debug your code. We're going to go to a sideline or a futuristic sideline where people are just going to say their code, and the code is going to be written by an AI. So you have to by now be practicing or be improving yourself on how to write a proper, functional, and clear code where somebody is able to understand what you're trying to do at each step of the way. So use pattern matching, do the work instead of if and else cases where you're trying to say if this exists, do that. If this, so with pattern matching, you can do a with. So in Elixir, we have this with statement. Use with for clear error pipeline. So you can use a with to say if okay the user gets user ID. So if we go back to this initial function here, we can say fetch user ID will give us a okay and a user. So if the user exists, transform the user, and if the data from the user is available, immediately send a mail. So it's something like this also with the wait, to say, okay, the user, you get it from this user ID. If you get a user, then from auth the user, you pass the user, you get a token. If the token is in existence, you can use it and authorize the person. As error unauthorized, give the person an S statement to say else unauthorized. This way, there is the code is being compatible, is being compressed to a very small and scalable and understandable code. You don't want to write a very large extent of code and somebody reading through your code cannot even grasp what you are trying to do. So always write your code like, see, you are going on a journey and you are doing a roadmap for somebody, because a wrong roadmap can lead somebody to their village or to a wrong destination, but a right roadmap will lead somebody to where they are going to. So we are going to the next principle that said fault tolerance with supervisor. So in Elixir, there is this statement that let it crash. So what do they mean by let it crash? If there is an error in the system, instead of the system trying to like find the solution, let the system crash, let everything crash, then the supervisor immediately kills that process and start a new process again. And when you start a new process, it start a new process with a new build, meaning that it's trying to check the code, is everything compatible. That's why you have to write a proper test case before you move to production. You have to have a unit test, the same thing, have a manual and automated test. Manual test is being done by the developers, is being done by the QA team. The automated test is done by the unit testing to test your codes, test bug, test error handling, make sure that all these things are in place. Use supervision tree, isolate errors to processes, prevent system-wide failure. Use tasks to break down your work or break down the flow of your work into various tasks. So we have asynchronous or tasks. You can run a send email through tasks so that if the send email fail, your whole application does not crash or the whole system does not just break down. So GenServer plus supervisor is equals to resilience. In your building project, in your building goal, when you are building a project, what is the key front on your head? What is the vision for that project? What is your mission for that project? What are you thinking now? What is in your backlog? Principle 4 say width and fallback. So we have heard of fallback. This is not, being a developer, this is not the first time you might be hearing of fallback. So what's a fallback statement? A fallback statement is a statement that you want the system to pick up. So for instance, now I'm going to tell you what I'm going to explain why I said code like if you're on a journey. So a user IJ exists in this system. IJ wants to go to the market by 3 p.m. She set her alarm to go to the market by 3 p.m. She went to sleep. There's supposed to be a fallback that if IJ does not wake up by 3 p.m., then there's an error that says, oh, market start is not handled. At that point in time, the system does not break because maybe after IJ goes to the market, she's supposed to buy grocery and so many other activities are supposed to happen in the system. But since she didn't go to the market by not waking up early, you have already put an error over there to handle that particular scenario. So that way your code does not break, your functionality is not in jeopardy. What you are building does not have to everything does not have to fail because of one bug. We have seen a situation where coding principles such as putting a comma, putting a semicolon can cause the breaking of a statement. Not a database value not being found can cause the breaking of a statement. Telling the user to do X, telling the user to do Y, and not putting a reference that X is important before they go on Y, and the user just do Y and submit the form, can lead to the breaking of a system. So to avoid all these things, that's why we need to use width for proper flow of the whole function they are building. And a fallback case of, oh, when this chain operation, when something happened, then at this point in time, let the system fall back to this else case. So principle 4, sorry, the principle 5 is document your design. So whatever you are doing, documentation is important. We have in Elixir, we have module doc to document the whole module. We have add doc to document the whole function. But I said it that documentation starts even before your implementation, even before your functionality building. I got to learn this from my CTO recently. So I was building these tasks, and I just dive into writing the code, and he asked me for a flow. Like, okay, how does this task flow? What is the flow of this task? And at that point in time, I was going back to my code to be like, okay, yeah, yeah, yeah. But I realized that if at a point in time I miss a step in writing this my code, there is no check for me to check, oh, you missed this step. So that documentation help you to, so when you do a documentation, from the documentation you do a roadmap. So you follow that roadmap to say, oh, step A is to find the user, step B is to transform the user, step C is to send the user email. Okay, that means I will need, so you know the kind of data you need, you know the kind of functions to write, you know the kind of way the UI is. So in your mind you have structured everything. Then in a paper you have put what is in your mind, you have put it into a paper, or you have put it into a Word document, depending on how you write your documentation. So you have put all these things into place before you start coding. So there is no way that your system is going to break or your system is going to fail at a point in time. So you keep architectural visible. Use Livebook for living documentation. So you can even use Livebook to write a function and do a proper documentation of the function. And at the same time, when you're building API, if you don't do a proper documentation for API as a backend developer, you put more workload on the front end developer, because the front end developer now has three tasks. One, they now have to understand your API integration you did. Two, they now have to know how to utilize it. Three, they now have to utilize it. That's a lot of workforce on them that is not their responsibility. So please do your due diligence while coding. Your due diligence does not mean writing the code, it does not mean implementing the code, it goes beyond that. So structure your contents. This is a bonus topic I'm going to add. Structure your contents. Make sure the logic of your file. So if you're doing account, make sure everything about get user, transform user is in account, and product will just carry get products. Every functionality you need about how to work with the product database should be there. Then in the payments, make payments, transaction, receipt, everything you need for a user to be able to initiate payment and everything to process a payment. You put everything in a different context file. So by putting all your work in different context file, you are creating this individuality, but you're creating this uniformity where each person is able to understand, oh, this function, when I'm looking at it, oh, I can get from this context file, I can get from this module, my answers can be found here. So you make life easy for yourself as a developer and for other developer coming to the team. So recap of what we said, we talk about pure functions, we talk about doing breaking down your tasks into smaller and reusable functions. We talk about pattern matching, using a with statements, using using less case and less if statements. We talk about supervision and fault tolerance, building supervision, let your system crash, let the supervisor pick up a new processes, rerun your code and try to see if there was any relapse of why the system can, proper error handling so the system can let the developer and let your user know what is happening. So if it's the user first, the user will put the right information. If the developer do not handle a case properly, they are able to go back and restructure their work and see where there was a loophole. So we talk about struts, not map. So using struts when you are doing, sorry, this was the part that got missing. So this part is talking about struts, not map, meaning that when you are trying to work with a database structure and you have to like create a user, you're expecting a struct, you're not expecting a map. So you try to follow all the whole functionalities you can use with a struct, not confusing a struct for a map, knowing when to use a struct, knowing when to use a map, knowing when to use a string, knowing when to use this data type, knowing how to implement them. The basis of every programming language is how do you structure yourself when you start. The basis is in the data type, the basis is in the variable, the basis is in the syntax. How is your level of understanding this basis? How much did you understand it? Because if you create a good coding system and a good principles for yourself before you start coding, it makes you have an easy and smooth journey when developing a task. So the fifth one is document everything. Everything needs to be documented for your improvement, for your confidence. So in the future reference, when they are asking you, oh, have you built a payment application, your documentation, you can go back to say, yes, I built a payment application. These are the SYZ, these are the steps I took while building their payment application. Oh, yes, I built a social media app. This is what I did. So documenting your process helps you on the long run to know how much productive you have been. So this, I'm coming to an end of this video today. So I'm going to say, let's build smarter. It's not about hard work. It's not about fixing code. It's not about writing the largest length of code line. It's not about writing the most impressive code. It's about writing a code in a smarter and reusable way. Writing a code that when you come to the system in 50 years, by reading through your code, you are able to understand what were you trying to achieve during this process. So thank you all for staying in tune with me today, and please subscribe and share to your family, friends, and anyone. And once again, this is Code with IG.